Hey guys, so we've been doing transformations and by now you've done a bunch. So we're going to talk about all of them and we're going to do them in a certain order. So I have this list here and we're going to talk about how you're going to do these and what that looks like. So the first one you're going to do is your H value. That's your horizontal shift, and that's really what it's called, horizontal shift. And what we've been referencing it as is a shift left or right. Okay, so you're going to do that one first. Okay, so I've been trying to color code as I work on stuff. So the second thing you're going to do, this is really 2A and 2B. So 2A is you're going to do a dilation. We're not going to do a whole lot with it. You guys had to do a little bit in one of the units or one of the notes when it's a number in front of your x value. So let's say we've got one's got this quadratic here. This is the dilation I'm talking about. And the reason it's 2A and 2B because if you have a reflection in there as well, that's your reflection over your y-axis. I want to make sure that if you have, for example, if this was negative 2x plus 2, this whole thing squared, you can do these at the same time. You can do them in 2 mini steps, or you can do it at the same time, but you would do this reflection as part of a step 2, or like a mini part of a step 2. So that would be 2A and 2B. I want to make sure you guys know that. Again, you're not going to do a whole lot with discussing that little transformation, but you will do a lot with the reflection over the y-axis. So I just want to make sure you have all that information. So then the next one, again, it's sort of a 3A and a 3B. Again, the D means dilation, and then the R means reflection. I'm going to show you what those are. So this is when you have A. So if you recall, if there was a number in front of your function here, you would do this dilation of 2. Okay, and then the reflection, if you have one, would be a reflection over your x-axis. So let's say that was a negative 2. You would do that in this step. Okay, so you just need to make sure you're doing the reflections in the right order and the dilations in the right order. So you should start with your inside. You do those ones before you go to the outside. Okay, so just remember you do your H value, then you'll do your inside dilation and reflection, and then you'll do your outside dilation and reflection. And then the last thing that you do is your vertical shift. In here, we've been talking about a shift up or down, and that's that K value. So that I'll put that over here in parentheses. That's that K value that we're looking at. That will always be done last, no matter what's going on in here. Your K will always be done last. All right. So we have this example below. We're not going to do. I'm not going to have you guys do this one. We'll do a few more together. So state the order in which the transformations occur with this function. So we've got f of x equals negative x minus 2, the whole thing is cubed minus 4. So the very first thing we're going to take a look at is that minus 2 right there. So that's your h. That's your h value, your horizontal shift. And because it's a minus, it's actually going to be a shift right 2. Okay? It's the opposite of what's there. So then if we are looking at our list and what we've talked about, the second thing we're going to do is this negative in front of the x, that's a reflection, and that's going to be over your y-axis. Remember, inside y, inside y. Okay, we do not have an a in front here. It's just 1, so then there's no reflection there either. So we're going to move on to our k value, which is, again, the last thing that you do, and that's our k value, and we're going to move down 4 because it's negative. And that's it. That's how you would list it. As long as you have the right transformations listed, just make sure that your wording makes sense. We're going to take a look at a couple more examples. So we've got number 4 here. Write an equation of the function whose parent function is, we have a cubic, or not cubic, quadratic, excuse me, and it has been vertically stretched by a factor of 3, translated 10 units left, and reflected over your y-axis. So we need to write an equation of what that looks like. So f of x is going to equal, okay, again, this isn't the right order, but they're listing what you would do. So it doesn't, let's see, it translated 10 units to the left. It's a shift horizontally. Left, if you remember, is going to be plus, so we're going to do x plus 10, the whole thing squared. Okay, we have a vertical stretch of a factor of 3 and a reflected over the y-axis. So the reflect over y-axis, if you remember, is inside y, so we're going to put that negative with the x. And then a vertical stretch, a stretch itself is when a is greater than 1. So that we're going to put the 3 in front here. So your equation should look like that. The 3 times the x minus, or 1, excuse me, 3 parentheses negative x plus 10, the whole thing squared. Okay. All right, I want to move down. I want to take a look at creating an equation from our graph. All right, so like for number 1 here, it says describe the transformations necessary to transform the solid line to the dashed line. So this is the one we started with. This is our parent function. It just happens to be, and then we're going to figure out how they got the dotted line one. Okay, so our parent function, and I know it's the parent function because we have our vertex on 0, 0. 1 squared is 1. 2 squared is 4, and then the rest of it follows suit. So I know this is my parent function that I'm starting with. I can put the x squared there. And so if I'm looking at my dotted, I can see that it shifted left from the vertex. It shifted left 3 units. Okay, so it went left 3. So if we go left 3, we can see that we should have a quadratic where I'm putting points right here. Okay. Oops, that's wrong. Here we go. Okay. So if I go just left 3, I should have the orange parabola. Okay, but I'm not obviously going just left 3 because we've got this green dotted one down here. So I know that it's been also reflected. It's a reflection over your x-axis. I'm gonna write that here. It's a reflection over my x-axis. Okay, so I should be able to flip this down, and I just need to check to make sure the points line up with this translated one. So my my vertex is right there. So this one point should line up with this black one right there. This orange point should line up with that black one right there. And then these other two should also be 1, 2, 3, 4 units away. So 1, 2, 3, 4. 1, 2, 3, 4 should also line up. So if they don't line up, that means we have a dilation, and we need to figure out what that dilation is. But because they line up, it doesn't look like there's any more transformations happening. So g of x should equal, we know that there is a shift left, okay, which is a +3. And we know there's a reflection over our x-axis, which is on the outside. It's not on the inside. So this should be my translated function. All right, so I want to take a look at number 2. Number 2 is an absolute value function. We're going from the blue, which is our parent function, to the green dotted, which is the g of x that we need to find. So we're going to go through our list. Do we have an h? Okay, so it doesn't look like there was a change from vertex to vertex. So you didn't shift left, you didn't shift right. So it doesn't look like we have an h value that we have to worry about. So if we're continuing, do we have any dilations or reflections? Okay, do we have any dilations or reflections? We does look like we have a dilation. Okay, it doesn't look like we have a reflection. So we need to take a look at what changed. So if we take a look at what changed from our input of 1, output of 1 right here, it looks like it went down to be about 1/2. If we look at this point right here, 2, 2, to get to that next point again, it looked like it went down 1. So we're gonna say if we were looking at this before our final shift up, okay, let's just address that. 1, 2, 3. It is a shift up. But to get from these 3 points, you would just go up 1 over 1, and now you're going really up 1/2 over 1, up 1/2 over 1. So really the dilation that you have is a compression. It's being compressed, and it looks like it's a compression of 1/2, because if you do your slope up 1 over 1 right here, okay, instead of it being 1 over 1 to get to each step, it's now up 1 over 2 to get to each new point of intersection. So to write our new function, our new g of x, okay, we can say that a is 1/2, because that's our compression. We do not have any reflections or anything like that that go along here. We do not have an h. So with the absolute value, we would just have absolute value of x, and then we can throw in the k value, which is +3. Okay, so to look for your dilations, the simplest way is to look at your new slope. We're not going to do a whole lot with your dilations from pictures, so if you have any, they're going to be pretty straightforward. Okay, so there's your absolute value. And I want to touch on a couple more examples before we get too far. So we have, let's look at our number 9 square root. Okay, we have negative root x minus 3, and then the whole thing is -6. I graph my parent function real quick. 1, 2, 3, 4. Okay, that's my parent function. I have a few transformations that I need to do. The first one is going to be shifting to the right 3, because that's my h. So I'm going to do shift to the right 3. So 1, 2, 3, 1, 2, 3, and we'll make that a dotted line here real quick. Okay, dotted. And then we're going to take a look at this reflection out on the outside. So remember, if it's a reflection on the outside, it's a reflect over your x-axis. Sorry, my pen's not working again. So that means you're going to flip down. So you're going to leave the 1 on the x-axis the same, and you're going to bring the points the same distance just across. You're going to go down. So then green is my second step. And then I have my K, which is my last step here. I'm going to go down 6. So all these points are going to move down 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then this is my final for my square root function. Okay. So now I'm going to create the domain and range for my new function. So my domain is going to start where my graph starts here. So I'm going to say it's including +3 all the way to +infinity. And then my range, remember, is if you're going down to up, I'm coming from -infinity all the way to this -6 right here. So -infinity, and I'm going to include the -6. So that is how you would do one like that. Okay? If you have any questions, come and see me during office hours.